Hi guys, this video is about doing a percent error analysis, and I'm going to go ahead and use my hot dog sales and my quadratic model as kind of a guide for you to take a look at. So first thing I'm going to do is I'm going to copy all this data over. And zoom in. Okay, so my quadratic model is this thing. Let's see if I can just copy and paste this over here. I'm going to delete it in a second, but I'm going to go ahead and write this down. Y equals negative 0.7771x squared plus 3025.8 minus 3 million. Okay. And I'm just going to write down the linear model too. I got a bad feeling about my 1 million figure there causing me some problems in terms of accuracy. Okay. So to do my error analysis, first of all, if you realize you'd like some extra space, you could click on, like, say, this number 6 over here, and if you right click and do insert, you get yourself another line. So a couple things I need in order to do this. First I need to make predictions, and to make predictions I would just write the equation, and instead of, oops, this should have had x in it, right? 3025.8x. Instead of where I see x, I'm going to put my x value. Remember, this is x and this is y. So I would write something like this: negative 0.7771. Now, you can't just write things next to each other in Excel. They don't like that. So you have to write times, and then I would do 2010 times 2010, that's squaring it, plus 3025.8 times 2010, and then minus 3 with 6 zeros. Okay, so you notice that I got a pretty big problem here, which is that my prediction here is negative 57,000 when it should have been something like 1589. This actually illustrates an important point about the use of years instead of translated years. I know we talked a little bit about that in class. I'm going to return to that in a second. Let me just scratch this out and say, well, this really is not going to work very well. And let's move over to the linear model. So I'll call this linear predictions. Linear predictinos. All right. So this should work fine. I'm going to take, again, I start with the equals, minus 104.13 times is the asterisk 2010, and then we add 210892, and that's my prediction. Now that makes a lot more sense, right? Because 1589 was the actual value, 1590.7 is my prediction. Now, the beautiful thing about the way I wrote this, instead of writing 2010, I wrote C8, which is a cell reference to where 2010 is. So here is the beautiful thing. If you click on this and you go to the right, you go down to the bottom right corner, you see how my cursor changed. Here it's a fat white plus sign, here it's a thin black plus sign. Bottom right, left click, drag down. This is called autofill. At each point, here it's C8, now it's C9, now it's C10. So Excel is smartly like updating each formula to change slightly to reflect that it's one cell down. So boom, it took me 5 seconds. I did the whole thing. I've got all my predictions. So this makes it very easy to do repeated calculations. Once you get the formula right, you don't have to worry about screwing it up the next time. It's a huge advantage over like trying to do this, one at a time on paper. Okay, now let us move over to the percent error situation. I'm going to give myself a little more space. To get more column width, go here, you drag it out. Okay, I'm just trying to get some more. If you double click, it gives you as much space as you need. So I'm going to go equals. Now, absolute value is a formula. So I do ABS, open parentheses, and then I write what I'm going to take the absolute value of. So here I'm going to do actual minus predicted. So that's this number minus this number divided by this number. Okay, actual minus predicted divided by actual. Really, the subtraction order doesn't matter at the top because I'm taking the absolute value. Boom. Last thing I'll do before I autofill is just automatically change this to a percent and give myself one more decimal place of information because 0% looks perfect. 0.1% is a better reflection of what's happening. Autofill. Bottom right corner. Click and drag. Bada boom, bada bing. How nice that is. And then I can apply my, if I want to take the average, I want to find the median, I can do those calculations on the number set. Okay, let me address this translation part because this quadratic model should work, but it's broken because I had to take the last number, which is kind of like a vertical adjustment issue, and approximate it as 3 million, but there was a lot more detail there. Better way to do it would have been to redo this. Okay, and again, I'm just going to get a blank slate here. To redo this by inserting a new column and saying years after 2000 or 2010, whatever you want to do. So this would be 10, 11, 12. With the translated numbers, I'm going to have a much better quadratic model that's more precise. It's going to give me better predictions. Let me show you what I mean. So again, highlight my data. I'm going to skip the part where I make the title and the axis stuff. Okay. Click on here, right click, add trend line. I'm going to a polynomial order 2 with the equation with the r squared on the chart. Okay, just a couple things to point out here. Notice that the a value of my quadratic model is the same, but the b value and the c value are different. And that is because of the translation I made. Okay. Notice that the r squared value is exactly the same because making the translation has no impact on how good the quadratic model is. It just changes what the coefficients are, which changes my ability to use it. All right. So I'm going to take this number, well, here, y equals negative 0.7771 x to the 2 minus 82.376 x plus 2478.3. All right, so I'm going to go ahead and copy this so I can have it on sheet 3, which is where I was doing my analysis. And I'm going to go ahead and get rid of this. Just to give myself the feel of having more tables and being organized, I'm just going to go ahead and copy this data down here. And that helps too because then I can make my translation, which is years after 2000. Need a little more space horizontally for that. So 10, 11, 12, use autofill here, bottom right corner. Not using a formula, I'm using a pattern. Excel says 10, 11, 12. Oh, you're counting, so if you want me to autofill, that's how I'm going to do it. All right, I'm going to bring this equation down here so I can see it and write it. Okay, so I'm going to go ahead and copy these two labels because they're pretty good. I just would need to change this one to quadratic. Okay, and then go ahead and write my formula. Equals negative 0.7771 times 10 times 10 minus 82.376 times 10 plus 2478.3. Okay, much better prediction, right? 1576.83. I'm in the right ballpark. Let's see how it works as I go down. Okay, seems like it's tracking pretty well. Probably don't need that many decimals, right? It's not a big advantage to having lots of decimals. It should not feel like having more decimals makes you fancier or have a better answer. Okay, and then I write my formula again. Equals absolute value of the actual value minus the predicted value divided by the actual value equals, I'm going to go ahead and change that to a percent. I'm going to give myself more information by increasing the decimal, and then I'm going to autofill here. Okay, so there you go. I've got my percent error for my quadratic model. I've got my percent error for my linear model, and that should help you kind of get started in thinking about things. You can clean things up afterwards, delete stuff. You can delete columns, right? Here, delete all those columns, just kind of gussy it up. You don't need to, but if you are the kind of person that likes to think about presentation, then that's definitely an option for you. Okay, I think that's all I want to say about the analysis part. Let me know if you're struggling with that. I can try to give you some individual help, or if you have criticism about my videos, feel free to let me know.